Welcome, let's start today's topic. Convert the purely recurring decimal 0.47, the repeated term here 47, to fraction. Okay, let's compute it here. So we can write 0.47, 47, the repeated term here 47 over 100, 47 over 100 plus 0.47, 47 and so on is equal to this 47 we can write 47 over 100 plus for this one how many digits after decimal point 1 2 3 4 so 47 over 10,000 1 2 3 4 10,000 plus for this one 47 1 2 3 4 5 6 47 over 1 million plus and so on. Now this is geometric series. This is equal to the first term 47 over 100 common ratio. This 47 over 10,000 divided by 47 over 100 common ratio will be 1 over 100. 1 over 100. So let's use the formula G1 over 1 minus R. G1 47 over 100 over here 1 minus 1 over 100 common ratio R. This is equal to 47 over 100 over here 1 minus 1 over 100 is 100 minus 1 99 over 100. This is equal to 100 by 100 can be omitted. So what will remain here? 47 over 99. 47 over 99. So this decimal number can be rewritten as a fraction form as 47 over 99. Let's look it here. So here is the answer. Since R is 1 over 100, 1 over 100 is strictly less than 1, so we can use this formula. After computing this all we get 47 over 99. Now let's go to exercise 1.21. Convert the following purely recurring decimals to fraction. Okay, let's compute A. Solution for question number A 0.4. The repeated term will be 4 and so on, which is equal to, let's rewrite this as a geometric series. This one 4 over 0.4 4 over 10 plus this one here 4 over 100 plus for this one 4 over 1000 plus again for this one 4 over 10,000 plus and so on. This is equal to, this is geometric series with the first term 4 over 10 and common ratio R 4 over 100 divided by 4 over 10 1 over 10 So here is the first term J1 4 over 10 over 1 minus 1 over 10 which is equal to 4 over 10 over 1 minus 1 over 10, 9 over 10, 9 over 10 which is equal to, let's simplify this, 10 over 10, 4 over 9. The simplified fraction form is 4 over 9. This is for equation number is 0.4. 4 over 9, let's cross check it. Let's divide 4 by 9. 4 divided by 9 is equal to 0.44 and so on. Now let's go to number B, 0.7 dot 0.7.77 and so on. This can be rewritten as a fraction form like this: 0.7 first term 7 over 10 plus next 7 over 100 plus next 7 over 1000 plus next 7 over 10,000 plus and so on, which is equal to, here we have, this is geometric series, the first term 7 over 10 over in bracket 1 minus 7 over 10 which is equal to, let's subtract this, 7 over 10 over 1 minus 7 over 10, 10 minus 7, 3 over 10, 3 divided by so read the common ratio are 1 over 10, 1 minus 1 over 10, 9 over 10, 9 over 10. After simplifying this we get 10 by 10 omitted 7 over 9, 7 divided by 9. So the fraction form for this decimal number is 7 over 9. Let's cross check it. 7 divided by 9 is equal to 0.77 and so on. So this is the correct answer. Let's go to question number C. 0.56 and so on, which is equal to, let's rewrite as a fraction for each decimal digit, repeated digit, 56, 0.56 over 100 plus this one 56 over 10,000 plus, because let's count it here, 1 2 3 4, yes, here 5 6 over how many, 1 2 3 4 5 6, 1 million plus and so on is equal to, the first term here we have 56 over 100 over here. The geometric series will be 10,000 divided by 100, 1 over 100. The common ratio R will be 1 over 100, 1 minus 1 over 100. This is equal to 56 over 100 over 1 minus 1 over 100 is 99 over 100. Let's simplify 100 by 100, which is equal to 56 over 99. Let's cross check it. $56 divided by 99 is equal to, yes, this is 0.5656 and so on. Application of arithmetic sequence and geometric sequences. Application of sequence and series in daily life. This section is devoted to application of arithmetic and geometric progression or geometric series that are associated with real life situations. Let's complete this activity 1.9. A man accepts a position with an initial salary of 5,200 Ethiopian birr per month. It is understood that he will receive an automatic increase of 320 ETB in the very next month, and each month thereafter. Find his salary for the 10th month. Here we have given the first initial salary 5,200. Again the common difference 320. What we need to find here? Salary for the 10th month, S10. Let's compute A10. Number A, we want to find A10. So let's compute it here. Number A, question number A, A10. A10 is equal to A1 plus N minus 1 times D. 10 minus 1, that one. 10 minus 1 times D. That is D. This is equal to A1, we have 5,200 plus 10 minus 1, 9 times. What about D common ratio? Common difference 320. This is equal to 5,200 plus 9 times 320. Let's multiply 9 times 320 is equal to 2,880. 2,880, which is equal to, now let's go add this, is equal, 5,200 plus 2,880. 5,200 plus 2,880, which is equal to 8,080. 8,080 will be the salary for 10 months at the 10th month. Now let's do question number B. What is his total earnings during the first year? During the first year, how many months are there here? 12 months. So what we want to find? The total earnings total. We want to find S total here. Total earnings S10. Let's compute it. S10. S10 is equal to S12. In one year we have 12 months. S12 is equal to 12 over 2 times A1, the first term, 5,200 plus AN, A12, that means A12. Let's write it here. A12 is equal to 12 divided by 2, 6 times. What about here we have A1 5,200 plus A12 can be calculated using A1 plus 12 minus 1, 11 times D. So here is 5,200 plus 12 minus 1, 11 times common difference D, 320. So this is equal to 6 times in bracket. Let's add this 52 plus 52, 10,000, 10, 4, 20 plus 11 times 320. Let's multiply 11 times 320 is equal to 3,520. 3,520. This is equal to 6 times 6 times. Let's add this. Plus 3,520 plus 10,400, which is equal to 6 times 13,920, which is equal to, let's multiply this by 6 times 6, which is equal to 83,520. 83,520. So this is the total earnings during the first year. Now let's go to question number 2. A carpenter was hired to build 192 window frames. The first day he made 5 frames, and each day thereafter he made 2 more frames than he made the day before. How many days did it take him to finish the job? So here we have given a carpenter was hired to build 192 windows frame. This is the total. Yes. Value will be, we have the first day he made 5 frames. Next frame 5 plus 2 7. Here we have 0. He made 2 more frames than he made the day before. These two represent what? Common difference, D. 5, this is the first entry. Next 5 plus 2 7, 7 plus 2 9, and so on. This is what? Sn. Let's use this formula. Sn is equal to n over 2 in bracket a1 plus an. Let's use this formula. Okay, let's write it here. This is equal to n over 2 times a1 plus again a1 plus n minus 1 times d. N minus 1 times d. So Sn we have given here. Sn 192, which is equal to, we don't know n, so what we need to find n value. So let's put it as it is, n over 2 times a1 plus a1, twice of a1 plus n minus 1 times d. N minus times d. What is d? D is 2 times n minus 1. Now this is equal to, let's simplify this again. We can take here common 2. Let's factor 2 n over 2. After factorizing 2 here we have 2n over 2 in bracket a1 plus n minus 1. a1 plus n minus 1, which is equal to, let's simplify 2 by 2. So we have n times n into a1 value will be the first day. We need 5 frames. So a1 will be 5 plus here n minus 1 as it is n minus 1. Now this is equal to 5 minus 1 4, so n times n plus 4, n plus 4. 5 minus 1 4, so we have n plus 4. n times n plus 4 is equal to 192. So let's here n times n plus 4 is equal to 192. Let's expand this. n times n square plus n times 4 4n is equal to 192. n square plus 4n minus 192 is equal to 0. Now let's factorize this, or we can use quadratic formula for this. So this can be factorized. n minus 12 times n plus 16, which is equal to 0. After factorizing this, you get this. n minus 12 plus 16, positive 4, we have minus 12 times 16 minus 192. So let's use product rule here. n minus 12 is equal to 0, and n plus 16 is equal to 0. So from this one we get n is equal to 12, and n is equal to minus 16. But n cannot be negative. So the only value will be n is equal to 12. This is the answer for question number 2. How many days did it take him to finish the job? The answer will be n is equal to 12. Here are some examples followed by exercises. The examples shown here and the exercises followed them illustrate some useful application. Example 1. Observe the pattern in figure 1.2. Okay, depending on this figure 1.5. If the pattern continues, find the number of letters in the column containing m's. Okay, let's list out English alphabetical letters. Here A, B, C, D, E, H, I, J, K, L, M, A, B, C, D, E, F, G, H, I, J, K, L, M, and so on. At what number M will be exist? M exists 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If the pattern continues, find the number of letters in the column containing m's. From this diagram, the first term will be 1, the next term, how many? 1, 2, 3. Next 1, 2, 3, 4, 5. Here we have 3, here we have 5. 5 minus 3, 2. Again 3 minus 1, 2. So the common difference will be d is equal to d is equal to 2. Again here a1, the first term will be 1. Common difference d2. Now what we need to find? a13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. A13. Let's calculate it. A13 is equal to A1 plus 13 minus 1. 13 minus 1 times D. D will be 2. So this is equal to A1, we have 1 plus 13 minus 1, 12. 12 times 2 is equal to 1 plus 12 times 2, 24. Which is equal to 1 plus 24, 25. So number of m's will be 25. 25 times is existed. This is for question number A. Now let's go to question number B. If the total number of letters in the pattern is 361, which letter will be in the last column? Okay, here we have given Sn is equal to 361. Let's calculate it here. Sn is equal to n over 2 times a1 plus an. What we want to find n. Sn is equal to, we have given Sn 361. 361 is equal to n over 2 times a1, the first term, we have 1 plus an, a1 plus 1 plus n minus 1, n minus 1 times d. D common difference, we have 2. N minus 1 times 2. 361 is equal to n over 2. N over 2 times 1 plus 1, 2 plus, let's distribute this 2 times n to n minus 2. 361 is equal to n over 2 times 2 minus 2, 0, we have 2n. 2 times n. Let's omit 2 by 2. So we have 361 is equal to n times n square. N square. Now let's rewrite it like this. N square is equal to 361. Let's take square root both sides. So n is equal to square root of 61. Square root of 61, let's calculate it here. Square root, where is square root? The square root of 361. 361 is equal to, the square root of 361, and then let's plus this 19. So n value will be 19. 19. What is the question says? If the total number of letters in the pattern is 361, which letter will be in the last column? This m is the 13 number. Next to them, n comma n comma n o comma p comma n o p q comma r comma s. Let's count it here. Up to this we have 13, 14, 16, 17, 18, 19. So let's count it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So which letter will be in the last column is S. The letter will be S. So here we have the answer. Also you can read from here. N is equal to 90, so the letter S will be in the last column. Let's do this. Example 2. A theater is filling up at a rate of 4 people in the first minute, 6 people in the second minute, and 8 people in the third minute, and so. After 6 minutes, the theater is half full. After how many minutes will the theater be full? So we have given here a theater is filling up at a rate of 4 people in the first minute. A1 is equal to 4, A2 is equal to 6. Okay, let's list out the given terms. A1 is equal to 4, comma, A2 is equal to 6, comma, A3 is equal to 8, comma, and so on. From this we can compute D comma difference D is equal to A2 minus A1, 6 minus 4, we have 2. Now let's compute. After 6 minutes, the theater is half full. Let's calculate S6. S6 is equal to 6 over 2 into A1 plus AN. A1 plus A6, that means A1 plus A6. So this is equal to 6 divided by 2, 3 times. A1 we have 4 plus, what about A6? A6 A1 plus 4 plus 5 times D, 5 times 2, that means. So here is S6 is equal to 3 times 3 into 4 plus 4, 8 plus 5 times 2, 10, which is equal to 3 times 18. 3 times 18, this is equal to 54. After 6 minutes, the theater is half full. This is half full. After how many minutes will the theater be full? How many minutes? After how many minutes will the theater be full? If this is the half full, the full form will be 54 times 2. This is half full. The full one here is the theater will be full. Full. 2 times 54, which is equal to 108. Now what we need to find n value. Let's use this formula here. Sn is equal to what we need to find here, n value. Sn is equal to n over 2 into a1 plus an. Sn we have here 108 is equal to n over 2 into a1. Here we have 4 plus n minus 1 times d. An will be a1 4 plus n minus 1 times d. N minus 1 times d. D will be 2. So here, let's calculate here this one. 108 is equal to n over 2 in bracket 4 plus 4 8 plus, let's distribute this to n minus 2 to n minus 2. 108 is equal to 8 minus 2 6. So here n over 2 in bracket 2n plus 8 minus 2 6. Let's simplify by 2. 108 is equal to n times n into 2n divided by 2n, n plus 6 divided by 2 3. So here we have 3. Again here let's rewrite formally. N times n square, here we have n square plus 3 times n 3n. 3n is equal to 108. Now let's rewrite this as a quadratic equation. n square plus 3n minus 108 is equal to 0. Let's use quadratic formula for this, or we can factorize this. This can be factorized. Factorize as n plus 12. 12 minus 9 3. N plus 12 times n minus 9 is equal to 0. So using product rule from this, n is equal to minus 12, n plus 12 is equal to 0, or n minus 9 is equal to 0. From this one, n is equal to minus 12, or from this one, n is equal to positive 9. N is equal to 9. But n cannot be negative, so the value of n will be 9. After how many minutes will the theater be full? At 9 minutes, the theater will be full. So, will be full at this is the answer. Now let's go to example number 3. A job applicant finds that a firm offers a starting annual salary of $32,500 with a guaranteed raise of $1,400 per year. What would the annual salary be in the 10th year? What you have to find here? 18. So here is, this is an initial value A1, that is A1. Let's list out the given condition. A1 is equal to 32,500 and common difference D is equal to 1,400. So let's compute. A10 is equal to A1 plus 10 minus 1 times D. We have 1,400 which is equal to A1 is 32,500 plus 10 minus 1 9 times 1,400 which is equal to 32,500 plus, let's multiply 9 by 1,400. 9 times 1,400 which is equal to 12,600 which is equal to plus here 32,500 which is equal to 45,100. This is question number A solution, 45,100. Let's go to question number B. Over the first 10 years, what you need to find here? The sum S10, the partial sum of the 10th term. So let's use this formula. S10 is equal to 10 divided by 2 into A1 plus A1, here we have 32,500 plus A10, that means A10 S10 is equal to 10 divided by 2, 5 times 32,500 plus A10 can be calculated A1 plus, that is 32,500 plus 10 minus 1, 9 times common difference D, 1,400. Now let's calculate this. S10 is equal to 5 times 5 into the sum of these two, 32,500. Let's multiply here. 32,500 times 2. The sum of these two times 2 is equal to 65,000 plus 9 times 1,400, 12 times 12,600. This is equal to 5 times. Let's compute again here. Plus 12,600 which is equal to 77,600. 600. So finally S10 is equal to, let's multiply this 5 times here times 5, which is equal to 388,000. This is value of S10. We can cross check it here. S10 is equal to yes, like this. Now let's go to exercise 1.22. The first question states like this: a person is scheduled to get a raise of per 250 every 6 months during his or her first 5 years on the job. If his or her starting salary is per 25,250 per year, what will his or her annual salary be at the end of the third year? So we have given here common difference into 250 every 6 months during his or first 5 years on the job. If his or her starting salary is 25,250 per year, what will his or her annual salary be at the end of the third year, which means fourth year, that means the beginning of the fourth year. We can take like that, so here is A3, we can calculate like this. A3 is equal to A3, which is equal to A1 plus 3 times 200, 3 times twice of 250, 3 times 2 times 250, which is equal to 25,250 plus 3 times 2, 6 times 250, which is equal to 625, 6 times, let's calculate 6 times 250, which is equal to 1,500. So 25,250 plus 1,500 is equal to 200,000. 25,250 plus 1,500 is equal to 26,750. This is the annual salary B at the end of the third year. Now let us go to question number B. Bond begins a saving program in which she will save per 1,000 the first year, and each subsequent year she will save 200 more than she did the previous year. How much will she save during the 8th year? Okay, here we have the first given thing. A1 is equal to 1,000. A1, which is equal to 1,000. A2 is equal to 1,000 plus 200. That means 1,000 plus 200, 1,200. A3, which is equal to 1200 plus 200, 1400. 1400. A4 here we have A4 is equal to 1400 plus 200, 1600. A5 here we have 1600 plus 200, 1800. A6 is equal to 1800 plus 200, 2000. A7 here we have A7 which is equal to 2000 plus 200, 2200. 2000 plus 200, 2200. A8 is equal to 2200 plus 2400. So the question says, how much will she save during the 8th year? So what we need to find here is S8. The sum of these all S8 which is equal to S8 is equal to A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7 plus A8. So S8 is equal to 1000 plus 1200 plus 1400 plus 1600 plus 1800 plus 2000. Here 2200 plus 2400. This is equal to 1 2 3 4 5 6 7 8. After adding this all we get, let's add in pair here S8 is equal to 1000 plus 1200, 2200 plus here again 1400 plus 1600, 3000 plus 1800 plus 2000, 3800 plus 2200 plus 2400, 4600 is equal to S8 is equal to, let's add this to 2200 plus 3000, 5200 plus 3800 plus 6600. That means 38 plus 66. Let's add 38 plus 66 is equal to 10,500 400, 10,400. This is equal to here you have 2,200 plus 2,400, 4,600. 38 plus 46. 38 plus 46 is equal to 84. 8,400. 8,400. Now the sum of these two, which is equal to 5 plus 8, 13. 13,000. 2 plus 4, 600. So how much will she save during the 8-0? The amount will be 13,600 per she will save. Okay, let's see this example. Example 1, minimum deposit per 3,500 in a bank account, paying annual interest rate. Annual interest at a rate of 6%. Show the amount she has in the account at the end of each year. Form a geometric sequence. Okay, let's show this. A woman deposited per 3,500. So for this one is G1, the first entry. Let's represent as G1. Okay, let's use this page. G1 is equal to 3,500. Rate R, which is equal to rate R is equal to 6%. 6%, which means this is equal to 6 times 1 over 100. 6 times 1 over 100, which is equal to 0.06. Now what will be G2? G2, which is equal to G1 plus G1 plus G1 times 0.06. 0.06 times G1. This is equal to, let's take common G1 into 1 plus 0.06. 1 plus 0.06 for G3, which is equal to G2 plus G2 times 0.06 times G2. This is equal to G2 will be here. Okay, let's take common G2 into 1 plus 0.06, which is equal to, now let's substitute this here. G1 into 1 plus 0.06 times this 1 plus 0.06 times 1 plus 0.06. Again, now let's compute G4. G4 is equal to G3 plus 0.06 times G3, which is equal to, let's take common G3 into 1 plus 0.06, which is equal to, now let's substitute this instead of G3. Okay, this can be right. This is equal to G1 times 1 plus 0.06 times 1 plus 0.06 can be rewrite 1 plus 0.06 squarized. Here we have again instead of P3 let's copy this here and paste it. Here we have times 1 plus 0.06 which is equal to G1 times 1 plus 0.06 power 3 here. 1 plus 0.06 square times 1 plus 0.06. Here power 2, here 1, 2 plus 1 power 3. For G4 like this. What about for Gn? Gn which is equal to, from this we can summarize, Gn is equal to G1 into 1 plus 0.06 is 1.06 power n minus 1. This represents what? The geometric sequence with first term G1 and common ratio R 1.06. This is geometric sequence. With common ratio R is equal to common ratio R is equal to 1.06. So this is all about today's lesson.